So now we're going to run through a full hypothesis test, including the calculations, and I'll show you how to do those calculations using your graphing calculator, and then come to our conclusions like we were practicing. So when the observed values are unlikely, when we have a small proportion or chance of that happening, under the assumption that the null hypothesis is true, we say that the results are statistically significant. Statistically significant. And we reject the null hypothesis. So we found a very small proportion or chance of this happening. It's a very unlikely chance. That means that we have statistically significant results and we can reject the null hypothesis. The level of significance will vary based on the problem. This is referred to as alpha. And I know we had an alpha back in chapter 7, but this is a different type of alpha. So alpha will be given to you in the problem. It's usually 0.05 because that's what we've been using this whole time. The level of significance will determine what makes something unlikely or likely. Usually we use 0.05 just like we've been doing. Any probability less than alpha is considered unlikely, and that's when we would reject the null hypothesis. Any probability greater than alpha is not considered unlikely, and we would not reject the null hypothesis. So it's just like on a normal curve. The likely is in the middle with bigger probabilities. The unlikely is in the tails. So unlikely on the high side or unlikely on the low side. So the probabilities, they usually cut it off at 0.05. Anything less than 0.05 is unlikely. Anything greater than 0.05 is in the middle of the curve and is not unlikely. So same idea as what we've been doing throughout the other chapters. Alright, so putting this all together, we're going to calculate those probabilities just like we did in chapter 7. So the normal curve is still true. We can still shade our area of interest. This time we're going to use a different function in the calculator. We're going to go to stat, tests, and use the one proportion z-test. We did the same procedure for confidence intervals, but now we're going to choose a different option, one proportion z-test. And it's going to give us a result that we're going to call a p-value, which we've kind of talked about that before as well. So we're going to state the null and the alternative hypothesis from the problem. We're going to run the test using what we talked about just a minute ago in chapter 7. And then we're going to state our conclusion based on the results. So we're either going to reject or fail to reject and use a complete sentence or two to conclude what we came up with for that set of data. So those three things, the null and alternative hypothesis, running the test, and then stating the conclusion. So again, this is under stat tests. It's one prop z-test. Prop stands for proportion. You're going to enter the value that they give you in the null hypothesis. You're going to enter what you have, the number of successes and the sample size, and then which way you're testing. The direction will either be not equal to, less than, or greater than. You're always going to choose the calculate option. We don't use the draw function in this class. So it will kind of walk you through the steps that it needs, and you'll enter the data it needs and run the test. Alright, so let's look at an example. I know these examples are pretty wordy. This author likes to give all the background knowledge for each example, so a lot of this we don't really need. What we're really looking at, we can kind of ignore all of this. We don't really care about the background knowledge. What we really care about starts after that bracket. An official with the Illinois State Department of Education wonders whether less than half of the students in her state are prepared for college algebra. She obtains a simple random sample of 500 records, so that's our sample size. She finds that 219 of them are prepared for college, so that's our X value, 219. And again, the 22 is just there to, he likes to fill in all those details, but we don't need all of that. So the question says, does this represent significant evidence that less than half of Illinois students are prepared for college mathematics? So we're going to state the null hypothesis and the alternative hypothesis. We're trying to see if the proportion is less than half. So we're going to start by saying that it's equal to 0.5. That's our innocent statement. We're trying to prove that it's less than 0.5. So we're trying to prove that less than half of the students are prepared. I like to draw a curve. You don't have to draw a curve for these. We've drawn enough curves. I think we've got it. So from here you can just run your test. You're going to go in the calculator. You're going to go to STAT, so S-T-A-T, over to tests, down to option 5, one proportion z-test. Your proportion you're testing against, your P-naught, is 0.5. That will be given in the problem. You're going to enter X and N. So 219 is X, N is 500. Students get those switched around a lot because of the way the problems are worded. So X always has to be a smaller number, and N is the sample size, which should be the bigger number. And it will calculate the sample proportion on its own. And then we are testing less than, so we'll go over twice and hit enter. Oop, not that one, the middle one, sorry. So you're testing not equal to, less than, or greater than. So we're testing less than, make sure it's highlighted in black, and then you'll always choose calculate. It gives you a lot of information. The first thing it gives you is the z-score. Sometimes the homework wants you to report the z-score. Usually only 2 decimal places, but there's all 4. So your z-score is negative. That means that our proportion is less on the bottom half of the curve. The number we want is that second number, the p-value. That's the number we're really looking for. 0.0028. The p-hat is just telling you what the sample proportion is, which is 219 over 500. You don't need that value. We're not going to do this by hand. Sometimes the homework will ask for that value, and so you will have to you can just read it right off the calculator. It gives you p-hat. So our value is 0.438 in our sample. We're testing against 0.5, and we're seeing how far away is 0.438 from 0.5 on the bell curve. And then it states your sample size again, which you don't need to write down again. We already have it right there. So really, all you're really getting out of this is the p-value. Sometimes it asks you for the z-score. So that p-value, we're going to compare against 0.05. So it says use alpha 0.05 for the level of significance. So 0.0028 is less than 0.05. What that's saying is that on the curve, our sample, this sample data here, our p-hat, is so far down on the curve that there's only a 0.0028 chance of it happening if 0.5 is our true proportion. So we're saying that it's a very unlikely result. If the result is unlikely, then we reject the null hypothesis. When we reject the null hypothesis, we're saying that we do have significant evidence to support the claim. And it just depends on what the claim is. Her claim is less than half of Illinois students are prepared for college mathematics. So the question, the answer would be yes, we have found a significant evidence to show that that average is that proportion is so far below 0.5 that it's very unlikely to occur. So we do have sufficient or significant evidence to support the claim that's stated in the problem. All right, let's try that again. So example 2, I think this is a gun ownership example. It says that 46% of all Americans said protecting their right to own guns is more important. This research center surveyed 1,267 randomly selected Americans with at least a bachelor's degree, so they were focusing on students that have gone through college. So their sample size was 1, 2, 6, 7. They found that 559 agreed with that statement. And we're trying to see if this result suggests that the proportions of Americans with at least a bachelor's degree feel differently than the general American population when it comes to gun control. And it tells you to use 0.1 as a level of significance. So we're going to make our statements. We're talking about proportions again, so we're saying that the proportion is equal to 0.46. We're trying to prove that the proportion is different or not equal to 0.46. So we're trying to see if it's significantly higher or lower than 0.46. We can go straight to running our test. Same thing in the calculator, stat, test, down to one proportion z-test. This time we're testing against 0.46. Our x value is 559. Our sample size is 1267. And we're testing not equal to, so we're going to push enter, make sure that pops up, and then down to calculate. Again, it gives us a z-score. Sometimes the homework asks for that. The number we really want is the second value, the p-value, which is 0.1794. The p-hat just tells you your sample proportion. It does the 559 out of 1267. Again, sometimes the homework asks for that number, but for us, we don't really need it. And then it reiterates the sample size. So again, we're really looking at the p-value. 0.1794 is greater than 0.1. So this is a likely result. Nothing weird's going on. It's not extreme. It's in the middle of the curve. So this time we're going to fail to reject the null hypothesis. That means we did not have enough evidence. So there is not enough or sufficient evidence to support the claim. So the question, does this result suggest the proportion is different? The answer this time would be no. We did not find significant evidence. So that's saying that 0.44 is not that far away from 0.46 to make it significantly different. So we don't have enough evidence to support that claim. So this should be pretty easy. The calculator's doing the hard part for us. We have to come up with our statements. We have to run our tests correctly and know what to compare, and then come to the correct conclusion. But now that we've kind of pulled everything together, this really shouldn't be too bad. So 10.3 is the same idea, but for means. The assumptions for means are different. We've talked about these enough in Chapter 8 and 9. I'm not really worried about the assumptions. Sometimes the homework will have you check. Remember that it needs to be stated in the problem. The sample size needs to be big enough, or sometimes you have to check the probability plot. I'm not as concerned about this because we've already done this enough in Chapters 8 and 9. So the process is the same. We do use a different option in the calculator. We use a t-test instead of a z-test in the calculator, since we don't know the population standard deviation. So you always choose t-test when you're dealing with means. So pretty easy, same idea. Let's see how this works with a couple quick examples. The first one says the mean height of American males is 69.5 inches. The heights of the 43 male presidents have a mean of 70.78 inches and a standard deviation of 2.27. So that's just the sample. Treating these 43 presidents as a simple random sample, Determine if there's evidence to suggest that the U.S. presidents are taller than the average American male. And then here's our level of significance. So same idea. We're going to start with our null hypothesis. I'm going to scoot this over a little bit. So our null hypothesis is that the mean is equal to what it says, 69.5. We are trying to prove that the mean is greater than 69.5 for this particular sample, that it's significantly different than 69.5. We're going to go ahead and run, sorry, this is HA. We're going to run our test. It's still under stat tests, except this time you run just t-test. So the second option, t-test. So we're going to run a t-test. It will ask you if you have data or stats. Data is when you have a list in L1. We'll do that in just a second. Stats is when you just have the stats, which is what we have. We don't have a list of data. We have the mean and the standard deviation. So we have the stats. Hit enter so that it's highlighted in black. The null mean, or the mean we're testing against, is 69.5. The x-bar we got in our sample, I always like to write that down, 70.78. And the standard deviation for our sample was 2.77. So our x-bar is from our sample, 70.78. S of x is our standard deviation from the sample. And our sample size was 43. So you can clear that out, 43. So again, the mean you're testing against, the sample mean, the sample standard deviation, the sample size. We're testing greater than, which is the third option. Hit enter so it's highlighted in black, and then calculate. This time it gives you a t-score, which we don't need, but sometimes the homework asks for it, 3.03. It's telling you how many standard deviations away your sample is, so in this case it's about 3 standard deviations away. We're again looking for that p-value, which is 0.0021. It restates the x-bar and the S of x and the n, which we don't need because we already have it right here. So p-value is what we're looking for. 0.0021 is less than 0.05, which means that it's very unlikely to occur. If it's unlikely, we reject the null hypothesis, which means that we do have sufficient or significant evidence to support the claim. So the question, determine if there's evidence to suggest that the presidents are taller. The answer would be yes. We found significant results and we rejected the null. So hypothesis statements, I like to write down my statistics on the side so I don't have to read the problem again. You run your test. The only number I'm looking for is that p-value, but sometimes in the homework it wants the t-score as well. Then you compare that p-value to your level of significance and make your conclusion. Let's do that one more time. This time we have a set of data. So it says the fun size of a Snickers bar is supposed to weigh 20 grams. Because of the penalty for selling candy bars under their advertised weight, the manufacturer calibrates the machine so that the mean weight is 20.1. So the 20 is not what we're going to use. We're going to use 20.1 for our mean weight. The quality control engineer at M&M's is concerned about the calibration. He obtains a random sample of 11 candy bars and weighs them and obtains the data in table 1. So this time we don't have a mean and a standard deviation. We have the actual list of data. Should the machine be shut down and recalibrated? Because shutting down the plant is very expensive, his alpha is 0.01, very tiny. So we're trying to see if these numbers are different, significantly different than 20.1. So our null hypothesis is that the mean is exactly 20.1. We're trying to see, he obtains, So calibrated means over or under, so we're just trying to see if it's different than 20.1. Are these numbers significantly different than 20.1? So this time we're going to put those values in L1 anytime you have a set of data. So clear out your L1. Let's put all 11 of those in L1. Watch your decimals here. Hit enter between values. You can go in whatever order you want. I always recommend just running back through them and double checking, especially since there's only 11. Just make sure you typed everything in correctly before you move on. Alright, and there should be 11, so your cursor should be on 12. Then you're going to go back to Stat, Test. You're going to pull up T-Test. This time we have data, so we're going to switch over to data. All it needs to know is what you're testing against. So for this one, it's 20.1. The list is in L1, so it will get the sample mean, it will get the sample standard deviation. Frequency stays at 1. And we're testing the not equal to. So not equal to, hit enter, make sure it's highlighted in black. So when you have data, the only thing you have to enter is the mean you're testing against. It will do everything else for you. Go down to calculate. So it tells you your t-score, 1.04, the number we care about, the p-value, 0.3226. It tells you x-bar. I don't think they'll ask for it, but it it gives you the average for the set of data, and it tells you s of x, 0.64, and it tells you the sample size, which you don't really need because it did it all for you. So we're looking at the p-value. That is definitely greater than 0.01. So that we have, that's a likely result. Nothing weird is going on. So we do not reject the null. That means that we do not have sufficient evidence. So, the question, should we shut down the machine? No. Nothing weird's going on. The results we got were likely. These numbers are fine. No need to shut down the machine. So that's chapter 10. It's a little shorter. Just getting the wording right is the tricky part. Running through the examples is pretty easy because your calculator does the hard part for you.